187 vertical order traversal of a binary tree. So let's first try to understand the problem. So we are given the root of the binary tree, and we need to calculate the vertical order traversal of the binary tree. Let me make a drawing. Let me just draw this example. Let's try to use this example. So we are going to get the vertical order. So for example, this is 9. So let's first study from the root. So for the root, so first index 0, it is the row, and the second index, it is the column. So the row 0 with column 0. And for the next node, so the column would be -1, and the row will be the next row, 0 plus 1, it would be 1. So this is the first column. Now we go to the right side. So row would be 1 plus 1, and column would be also plus 1. So for the column, the calculation is, if it is the left side, column would be -1. If it is at the right side, column would plus 1. So it is 1, 1. And then this go to the left, so the row would plus 1, and column left side would -1, 1 minus 1, 0, 1 plus 1, it is 2. So we're gonna get the result. So the first column, it is 9, we put 9 inside an array, and then the second column, it include, here is 0, here 0, this means the second column, it includes 3 and 15. So for this 3 and 15, if they are in the different rows, 3 will always be first, and then 15. But if there are two numbers in the same row, for example, there may be another number at the right side of 9, maybe this is 16. So the order would be 3 first, and then 15 and 16, because this is according to the description. If they are in the same row, we always choose, if it is in the same column, and then in the same row, we always choose the smaller number first. Let me explain this one. But let me first finish this one and explain that example. And then fourth column, we're gonna put it inside. Now let's try to check that example. Let's check the example 3. As you can see, this is a column with 4, 2, and 1, 6, 5. But it should be 1, 5, and 6. Why? Because 5 and 6 are in the same row, row 2. But it should be sorted in increasing order. 5 should be first, and then 6. But for that 1, it doesn't matter, because 1 is in the first row. It is the row 0, so 1 will be first. After that, it will be 5 and 6. Now let's try to start coding. Because the programming should be easier, it is just a BFS problem. We just need to traverse the tree by using BFS, and at the same time, we need to record the row and column. Because for the column, we're gonna put the column inside an array. We need the column, all the numbers would also be inside a subarray. So the subarray would be inside our result array. But for each of the rows, we need also to record, because if it is in the same row, we should also sort it. The smaller number would always come first. And now let's try to code it. Try to code it up from here. Let's try to use this example. But I also needed to use a dictionary because I needed to get the result of a list of arrays. So it would be default dict, and inside it would be list. Now I'm going to use the BFS, so I'm gonna prepare a double-edit queue. So inside the queue, I'm gonna put the root node and the row and column. So row would be starting from 0, and column would also be starting from 0, because this is for the root node, as it is drawing from here. We have a tuple of 0, and this is a row and column. Let me just make it. So this is root, row, and column. Now we are going to check the queue. So while queue, we're gonna take the node out, and here we're gonna have a row and a column. Let's just make a column. so it should be code dot pop left. Now we are going to check this. We are going to put the value inside the dictionary, because later on we're gonna use the dictionary to put out the result. So dictionary would be the d not dot value. Yeah, because yeah, let me just check. So inside the dictionary we need to output the column by column. Yeah, so actually we need some value like this -1 or this 0, because this is for the column, so this column would be the k. Yeah, so we're gonna use this column. D column should append a tuple. So first of all we need a row, and then we also need the values. So the value would be not dot val. Yeah, so the column would be the k, because we're gonna output the result by the column. Yeah. Now we are going to check if not dot left, we're gonna put it inside the queue. Queue should append. First of all, it should be not dot left, and then we're gonna put the row inside, so the row would be +1, and then we're gonna put the column inside. If it is at the left side, column would -1, and similarly, let me just copy the code, it would be the same. Yeah, if it is at the right side, queue should append not dot right and row +1, but column would also +1. Yeah, so this is the code for the BFS. After that we're gonna get a dictionary. Yeah, so what is inside of the dictionary? Dictionary is just key value pairs, but we need to output the result by the key of the dictionary. So k is the column, so we need to check the k first. So k in d dot case, but we need to sort it because we're gonna first output the left side and then go to the right side, column by column. So we need to sort the case. So we need to sort it the d dot case. So this is gonna be like -1, 0, 1, and 2. This is by the column. Yeah. Now we want to output the result. Let's just prepare an empty array. Normally this result should append the value. Yeah. So it should append like dk. But what is dk? Dk is a tuple at the moment, but dk should not be a tuple. Actually, we just need the values. But at the moment, dk it is a tuple of row and values. Yeah. Let me just return the result. Let's check what is inside first. Yeah. Now, as you can see, we just put it inside a tuple. Actually, we just need 9, 3, 15, like that, and 20 and 7. But here we have a lot of tuples, so we just need to return the tuples. Yeah. But this dk should also be sorted. Why? Because, like this example, if the value is 5 and 6, it is in the same row, row 2. Yeah, but 5 should be output first, and then 6, like 1, 5, and 6. So it means this dk should also be sorted. Yeah, now let's sort the dk. But still, outside it is a tuple. Let's check this result, example 3. As you can see, it is still a tuple, 1, 5, 6. Now the order is right, but it is still a tuple. But actually we just need like 1, 5, and 6. Yeah, where is the position? It is at the second index. Yeah, it is at index 1. So we just need to prepare the index 1. Now we put it inside an array. So we take out the items 1. So for item in the sorted decay. So in this way, we're gonna get the final result. Now, as you can see, we just get the final result. Now it is not a tuple. But why we need a tuple? Because we need the sorted decay. This sorted decay will first sort the rows, and then it will get the values. So if it is in the same row 5 and 6, we're gonna output 5 first and then 6. Yeah. So this is the entire code. Now let me submit it to Tag. As you can see, it's pretty fast. Now let's analyze the time complexity. As it is a BFS, so the time complexity is just On. We just need to traverse all the nodes, and the space complexity is also On. I believe because we just traverse all the nodes, it is the number of nodes, and the number of nodes is just 1000 in the tree. Thank you for watching. See you next time.